Hello, Ken Weller's NewTek Inventors. Down here at the print farm, doing the usual thing, running some printers. Having a little bit of problems right now because of the temperatures. We're in a little bit of a heat wave. Heat index today was over 100 degrees, I think about 103. And here in the print room, if you're running very many printers at all, it can get pretty hot. Right now, what I'm doing, I'm running the air conditioning unit on the other side, and it's helping to cool things down in here. We're down to about 88 degrees now, but it was up about almost 100 degrees in here earlier today when some of these printers were running. And a couple of the printers had some problems because we were out of that comfort zone. They like to run at 85 degrees. 85 to 90, somewhere in that range. But you get up around 95 to 100 degrees, that affects a lot of things. For one thing, I'm running with 0.6 millimeter nozzles on these printers, printing PLA, but I'm printing at 220 degrees centigrade. So 220 is on the high end for most PLA. And when you have real hot ambient temperatures in addition to that, that can contribute. One of the reasons I run at a little bit higher temperature is because I'm pushing a lot more filament through the 0.6 millimeter nozzle than I would be through a 0.4. So I want to give it a little more heat. But what I'm going to do tomorrow, when it starts getting really hot, I'm going to have to bring the temperatures down, probably drop them down from 220 to 215 or maybe to 210 to try to compensate for that. Because one of the problems I'm having is that when it completes the print job and the filament stops flowing, that hot end is so hot with the ambient temperature that the PLA going up into the PFE tube will actually melt a little bit up there, and then when it cools off it expands and it sticks in that tube right at the nozzle or the hot end. And the only way to get that free, there's two methods I've done. One is I'll heat up the printer and I'll run the temperature up to about 245 degrees, hoping, and then go ahead and try to extrude or force some filament through that tube. And sometimes that heat will get up in there and melt or soften the filament in the PFE tube that's swollen and allow it to push on through. And you can clear the clog then and get it going. Another way to do it, if that doesn't work, then you have to just actually take it loose right here, pull the whole tube out, take your little clippers, clip off the very end of that tube, and then push it back down in there. You can do that a few times before it gets too short. You don't want to get this tube too short where it puts it in a bind trying to print to the extreme right over here. But that's one of the problems that I have with it. Another thing too, and when I have that problem, and I did when I came in here, this thing was, sometimes it'll bump. You'll hear the extruder trying to extrude it will miss a lick. It won't be able to push the filament on through the tube as fast as it wants to, and every once in a while you'll hear a tick. A couple of things cause that. One, if your zero offset is too small and your nozzle's too close to this bed, then that will cause it to sometimes restrict the flow and put enough back pressure on the filament here at the extruder that it'll skip a beat there, and you'll hear that tick every once in a while, boom, boom. That's one thing that will cause that. Another thing that will cause it is if you have a nozzle that is not flowing good. And one thing I found out, I use a lot of brass nozzles on these because they're cheaper, but you can see I'm also using the textured spring steel sheet here. And that textured spring steel does a pretty good job, but one of the drawbacks is it's almost like sandpaper, and if you get any corner out of level slightly so that when it's going over there on that first layer, if that nozzle makes contact with this, that brass will have a tendency to kind of scale off on the nozzle in whatever direction it's going on here. And what it will do to that nozzle, it will cause the very tip of it to have a slight restriction on one side. And one sign of that is if you, before you print, if you try to extrude some filament, and I always try to do that before I start printing, especially if I've done any work on it, and I want to see a nice stream of melted filament coming out of that nozzle. If it comes out and immediately is curling up on you, then that's an indication to me that the tip of that nozzle isn't symmetrical and that it's been damaged and has some restriction. So it's better off to go ahead and I just replace the nozzle. They're cheap. I don't try to go in there and ream them a little bit at the tip to round it out again. But if they get out of round, it'll do that, and it can cause enough restriction where you don't get enough flow. If you don't get enough flow, a couple things happen. We're printing this little part right here, and it's a pretty strong part, and don't really have any problems. But if you have one that's ticking away and not getting good flow, you're not getting as much filament coming out of that nozzle. You've got a 0.6 millimeter nozzle. The slicer program and everything's expecting so much of that melted filament to be coming out to make this part, and if there's not enough coming out, it'll still make the part. But when it makes the part, it's not going to be as strong. It's going to be lighter weight. That's one way you can really tell fast if you've got a printer that's printing, even though it looks like it's printing a perfectly good part and the part comes out looking good, if it doesn't have as much filament in it as it's supposed to, it's going to be weaker. It's going to have thinner layers and less filament in between those layers, and it'll be very obvious that it's a weak part and it's going to break. As a matter of fact, I've had that situation, and it just so happens I have some parts that were printed like that. These parts, this is a good part here, good and strong. I can press on these, put quite a bit of pressure on it, and it won't break. These parts I just pulled out of the scrap bin. They look just as good as these. They look like they're good parts, but when you press on them here, it snaps and breaks. This one looks pretty good too, but you press it, it'll break. They're just not as strong as they're supposed to be. These won't break. I can put a lot of pressure on them. So if you ever have a printer that's not printing right, don't think you've got good parts, because you probably don't. If you're not getting the flow that you're supposed to have, the parts aren't going to be as strong as they should be. If it's a decorative ornament or something, it may not make a difference, but these parts have to be strong because they do a job for a customer, and we can't let anything like that go through. So if there's a printer acting up, doing that bumping, I know immediately. Stop it, fix it, and start over again. And another thing that we have is when they're printing these parts, if you notice, I'm printing them on the A-nets. I'm actually printing 31 pieces at a time on here. These are small parts, And as you can see on the bottom, there's not much of a contact surface there. So it has to make real good contact so that it won't break loose at some point. If one of these 31 parts on here, if any one of the 31 parts loses adhesion and breaks loose, it's going to end up destroying all 31 parts on the printer. So you have to really watch and make sure your zero offset's good, make sure your level's good, that all four corners are going to be the same on that first layer. It's very important that they get the adhesion then. And then after that, it should go ahead and finish printing fine. Some of these printers will print, and I have no problems at all with them. They just keep printing over and over and over, and I can print sometimes 30 batches or something that run, that means 30 days of printing without a single adjustment needing to be done. But eventually they're going to need some adjustment, or something's going to happen, and it's just part of the job, I guess. But right now I'm running these seven A-nets here running this job. I was running 15, but I cut back because it's so hot, and my vent fan has stopped working, has a problem, and I haven't had a chance to figure out what's going on with it, so I'm using the air conditioning on the other side to try to keep it cooled down in here. So cutting back on the printers helps keep it a little bit cooler. So I'll do that until I can get the vent fan going again. Not sure what's wrong with it. Anyway, those are a few of the things. In printing these parts, when these things print 31 at a time, and right now I'm printing a batch, let's say this order's for 7,200 of these pieces. So I have to print 7,200 of these pieces. And I'm thinking about putting them on some of the larger printers. I've got some larger printers where instead of printing 31 at a time, I can print, you know, somewhere between 80 and 100 at a time. The only problem with that is if you have any one of those single parts messes up, it can blow the whole job and you lose, you know, 100 pieces instead of just 31. So if I've got enough printers, which I do, you can see I've got plenty of A-nets here that can run this thing, and if everything's set up correctly, when these parts come off of here, they come off looking just like this. There's no stringing, there are no burrs on them, there's nothing that has to be cleaned or anything on them. They go right in the box, and then they go over and go into this box here, and then from here we bag them up. We have bags that we put them in, and then we weigh those bags on the scale, and 1,049 grams, or just a little bit over 1 kilogram of weight, is going to give us 250 pieces in a bag. So we bag them 256 pieces at a time. And that's another reason that you want to make sure that you don't have a problem and you're printing weak pieces with less filament. They all need to weigh the same, or our count isn't going to be good either, and we'll be cheating the customer, or actually we'll be giving them more parts because they'll be lighter weight, but they won't be good parts. So the whole goal is to make sure every part they get is a good part and that the count's correct, and that's the way we do it. So that's a little bit about the printers. Let's see, what else can I tell you? You have to have certain tools ready. I've got these wrenches everywhere, because if I do get a clog or something, I can very quickly disconnect the PFE tube there, pull it out. Got a wrench here so I can change the nozzles. I keep nozzles handy. You can see that I've got, that's a good one there. I'm sure there's several bad ones laying around. And the hot ends and stuff, every once in a while they have to be replaced if they get bad enough. So there's a lot of maintenance, and when you're running printers 24/7 and you have to depend on them, you have to expect maintenance every once in a while and do it. And if you do it enough times, it doesn't take that long. It just takes me a couple minutes to clear a clog, change a nozzle or whatever. Now if you're using identical nozzles, that's one thing, but now if you're changing nozzles by type to a different type, then you have to reset your zero offset and everything, because changing that nozzle will affect the zero offset on these printers. Also, every time you got to check them every once in a while. The belts seem to last a long time. I don't have too much of a problem with belts. I think I have one right here with the belt problem that I'll be working on. But normally I don't have problems with the belts. I just have to check the tension on them every once in a while, because sometimes they might start to loosen up a little bit. These rollers, I adjust them ever so often, because you'll get a little bit of play either in your bed here or on this guy up here. This one has no play at all, and all of my printers should be like that. If they ever get off a little bit, then I immediately get to work and tighten them up a little bit. Don't get them too tight, but just right. And if you do that, they'll just keep on ticking. So that's a little bit about the printers. I wanted to do this video because I haven't done a video in a while, and most of the subscribers to my channel are people either involved in 3D printing or wanting to get into 3D printing. And the whole purpose of my channel originally was to help people that want to get into 3D printing, encourage them and show them how I would go about it. And if you go look at the earlier videos, when I started, I knew absolutely nothing about 3D printers. I just went out and bought one and tried to start printing with it, and saw where you had to have an STL file to be able to print something. You've got to get your 3D image into an STL file. So I downloaded a free copy of Autodesk 123D, did a little drawing, got the STL file, copied it to a little chip, plugged it into my little printer that I bought and assembled. My first printer, I purchased it as a kit online, and it was like $85 on eBay. This was in 2019, December of 2019, my very first printer. Put that chip in there. Couldn't get my STL file to print. I couldn't get it to print. I was trying to figure out what's wrong with this printer. And so then I thought, well, you know, like all men, there comes a time when you should look at the instructions and read. And so I started reading the instructions and saw where a chip came with the printer, and it had a copy of Cura slicing software on there, and you need to slice that STL file. So I downloaded that on my computer. I sliced the STL file, generated a G-code file, copied that onto my chip, put it in the printer, and what do you know? The darn thing printed, and it printed that part, and I was so amazed that it could do that I could draw a 3D image and get it onto a chip and get the printer to actually print it out with this filament, that I was hooked. and the rest is history. But if you go back and look at some of the older videos, you'll see where I first got started and figured that out, and I purchased a few more printers, and then I decided, you know, I could make a business out of this. Well, I had just retired from the construction business and thought I was getting ready to enjoy my retirement and maybe have a hobby, but I had this wild idea that, hey, this could be a business. So I'm going to start documenting how I'm going to make a business out of 3D printing. And I'm going to do it. I think I was about 73 years old at that time. So here this 73-year-old man's going to do a business through COVID and everything else and document it on YouTube. Well, that's what the videos depict. I did that, and well, I was successful in several areas. I had it was a learning process, and I made a lot of mistakes, but I documented a lot of that, so hopefully somebody else that might want to try it won't make those mistakes. But you should be encouraged knowing that someone in my older generation, a baby boomer, could pick this thing up at the age of 73 and learn how to do it and make something out of it. And even though I've got the capacity here, I've got this print room that's got everything I need. I have over 100 printers, over 60 of them in this one room. And I've never had every one of them running at one time. I've had about 10 or 12 up at the house in my bonus room running at the same time that I've had maybe about 30 down here running, but that's about the most I've ever had at one time. And the reason for having so many printers wasn't so I could run them all at one time. It was so that I would have certain printers set up and designated to print certain parts for me, because I was going online and selling some products that I was making. Also, I'm making parts for other customers, custom parts, and I have certain printers like these right here set up to run this part with a 0.6 millimeter nozzle. But then you can go over here and look see that these printers are set up with 0.8 millimeter nozzles, larger printer, and they're used for printing something else. And then I have some printers that have 0.4 millimeter nozzles because I'm printing smaller, more detailed parts that need a little more accuracy than you get with a 0.8 or even a 0.6. And then I even have one very crucial little thing that I'm printing with a 0.1 millimeter nozzle because I'm needing extremely high accuracy and detail in that part. So what you're doing, you're sacrificing detail and accuracy for speed when you go up in the nozzles. And if I was printing this job with a 0.4 millimeter nozzle, it would take me over a day to print this job. But I'm printing it take over 24 hours. I'm printing it in 16 hours. So it does print considerably faster with 0.6 and even faster with the 0.8. So it depends on the parts that you're printing. If it's a larger part, some of the parts, one part that I print for a customer are these boxes right here. And these things take about 1 kilogram per unit to print, and I can print them in 23 hours, and they print on these printers with a 0.8 millimeter nozzle. So if I printed it, I put it in Cura just to see what it was, and to print that with a 0.4 millimeter nozzle, it was going to take, I think, about almost a week to print continuous. But if I print it with the 0.8 millimeter nozzle with certain settings on these A8 printers, A plus printers, I can print that in 23 hours. So I can get one of those a day per printer when I'm running that job. So that's some of what I've been able to accomplish. But right now, I've gotten into some RV stuff. I've been taking trips. I'm going to take some more trips, and I like to do that stuff, so I don't want to be tied down here. And my grandson helps and runs some of this stuff, but I'm not looking for any additional work. I don't really want to overload myself, but I do enjoy being able to do special jobs and print parts and get them out. We've got a large inventory next door of the parts for the items that we sell on the website, and as some of those inventories get low, then we'll print some more just to stock back up there. But so anyway, that's a little bit I thought I'd pass along. I try to help people by giving them tips on things to watch on these printers, things to look for, and different problems that you could have. So I hope some of these videos have been helpful. I definitely want to encourage anyone out there, especially anyone younger, that is thinking about getting into 3D printing. It's unlimited what you can do. If I was 35 years old, I could be running 200 or 300 printers at the same time. I would have a big operation. I could get the work. It's out there. Anybody thinking about getting into 3D printing should go ahead and go for it. Get a couple of printers. They're cheap. You know, for a few $100s, you can get a printer. Filament's cheap. This filament here costs less than $10 a roll or a kilogram. So there's no reason why you can't print stuff for people. The 3D CAD software isn't that hard to learn how to use. You really do need to learn the 3D CAD software, and there are a lot of them out there that will allow you to generate a 3D image and export it as an XTL file. And then once you have that XTL file, just download a free copy of Cura and slice it for your printer and put it in that printer. Experiment around with that. In that STL file, you can set a lot of parameters. One of them, you know, your retraction and stuff. When the print head's going down printing a part and then it wants to jump to the next part, it extracts some of that filament, sucks it back up into the nozzle, so it won't leave a string of fine thread of filament going from one part to the next. And then when it gets to the next part, then it starts shooting the filament out again and printing that next part. So there's a speed and a distance of retraction that you can adjust there. So if you're getting any string or something, adjust that, and then you'll be able to get parts that when they come out, when you're printing multiple parts, that won't have little dimples on the outside of them where it moved from one part to the other for each layer. So that's a tip there that you do in that Cura software. Also your temperatures and a lot of other settings there. That your first layer is important, and you can set parameters for that first layer, and you can set a different speed for the first layer. You can print that first layer at a slower speed so you can get a real good first layer. That first layer is so important because that's what determines your adhesion. So you have to get it right. And once you've got that first layer, you're building on that. It's like a foundation to a house. When I was in the construction business, that was very important. You have a poor foundation, your house is going to be built either out of level or with a dip somewhere. So the foundation is very important. First layer is the foundation. Get that first layer right and you're on your way. And there are a lot of different ways to level these things. I have some certain ways that I do the leveling on these manual printers here, where I have to manually set the zero offset and manually set leveling on them. But on the ET4 Pros and this is the ET4X. The ET4s and ET4 Pros are the ones that have auto leveling. So I think I've rambled on long enough for now. I just wanted to, like I said, to get a video out. Notice there's new subscribers subscribing even when I'm not doing videos, so I want to at least do the courtesy of getting a few videos out. Let me know what you think. If you have any questions, ask them in the comments. I always answer all of my comments. So I guess until the next time, happy printing.